Section 5.3, Rate of Change in Slope. In Section 5.3, you're going to see a lot of slope taking place, and this might be review for you. But we're going to look a lot at what's called rate of change, and there's a formula for rate of change along with the slope formula. So what rate of change is, it's a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. Remember, your dependent variable is your output, your y, and your independent variable is your input, x. So there is a formula working with rate of change where you have your change in your dependent variable over your change in your independent variable. Change in dependent variable means you're going to be subtracting your y's, and change in independent variables meaning you're going to subtract your x values. We're going to talk about a little bit in this section rise, the difference in the y values of 2 points on a line. Run is the difference in the x values of 2 points on a line. So we can say the difference in the y value for your rise, for your run, the difference in your x value. Your slope is a ratio of your rise to run for 2 points on a line. And when you're working with slope, there's a formula which is very similar to rate of change. Slope is rise over run, or you can think of change in y over change in x. Similar to rate of change again, change in dependent, change in y, change in independent, change in x. Another way to think of slope too is y2 minus y1 over x2 minus x1. That's going to help you, the changes in the dependent y and the changes in the independent x. You will also see different types of slopes in this section. Slope can be positive, negative, zero, or undefined. You can tell which of these is the case by looking at a graph of a line. You do not need to calculate the slopes when they're wanting you to recognize them. So notice the first slope provided for you is a positive slope. And I think of this, like I said in class, of going up a chairlift when you're skiing. You're going to start from the bottom and it's going to rise from left to right. That's positive slope. Negative slope, think of when you're skiing down a hill, you start at the top and go down. So your negative slope line falls from left to right, so it's going down. Your horizontal line, we call that a zero slope. And a vertical line, that would be an undefined slope. Let's get started with some examples here. So example number 1, it says the table below shows the balance of a bank account on different days of the month. Find the rate of change for each time interval. During which time interval did the balance decrease at the greatest rate? So what we're doing in this example here is we're answering two parts. We're first going to find the rate of change for each of the time intervals, and then we're going to answer the question, did the balance decrease at what time did the balance decrease at the greatest rate? So when we're finding this, we need to think of our rate of change formula. Where we have our change in our dependent, which is my y, over my change in my independent, which is my x. Or think of it like this with my y's, y2 minus y1 over x2 minus x1. So between intervals, we're going to separate this between each. So we're first going to look at between 1 and 5 with the balance of 550 and the day 6 of a balance of 285. So I'm going to look at these two situations first. I have my x1 here, my x2 is my 6, my y1 is 550, my y2 is 285. How did I determine my x1, x2, y1, y2? Well, it just goes in order. So day 1 is my first, so x1. 6 is my second one, so that'd be x2. So let's set this up using the rate of change formula to find the rate of change of this time interval. So I would do y2 minus y1, which y2 is 285, minus y1, which is 550, over my x2 minus my x1. x2 is 6, minus x1 is 1. So now let's solve. 285 minus 550 is a negative 265 over 5. Negative 265 divided by 5 is going to give me negative 53. So the time interval from the first to the second is negative 53. So from here to here, we could say negative 53. Now let's look at my next interval. That is going to be 6 and 285, and then 16 and 210. So to solve that, I would have 16 minus 6, y2 minus y1 is 210 minus 285 over 16 minus 6. 210 minus 285 is negative 75. 16 minus 6 is 10. So my second interval is going to be at a rate of change of negative 7.5. Let's look at the next interval we have. The next interval would be 16 and 210, 22 and 210. So I would do 210 minus 210 over 22 minus 16. I would have 0 over negative 14, which simplifies to be 0. So the rate of change between these two intervals is 0. The very last interval, my rate of change, we have 22 and 210, 30 and 175. So I would do 175 minus 210 over 30 minus 22. 175 minus 210 gives me negative 35 over 8. Negative 35 over 8 is going to give me negative 4.375. So the interval between these two times is negative 4.375. All right, so now that we've found the rate of change between each interval, we now have to answer the second question, which is asking, during which time interval did the balance decrease at the greatest? So which of these values is the greatest value that it decreased at? And it's going to be this one right here, this negative 53. So we can say from day 1 to day 6, the cost decreased at the greatest rate. Okay, so that's working with the rate of change problem with intervals. Sometimes too you might see tables with intervals like this, and you'd have to graph them and find the rate of change between that. So you'll see a little bit of that in the book. Going on to the next example, this is where we're going to be finding the slope. Finding the slope of the line that contains 2 points, 0, negative 3, 5, negative 5. Remember, slope is rise over run and we think of that as change in y over change in x, and we can think of that as y2 minus y1 over x2 minus x1. So when I'm given 2 points, I can label them as x1, y1, x2, y2. Why did I label it like that? Well, I just chose my first set of ordered pairs as x1, y1, my second set of ordered pairs x2, y2. So now, using the formula for slope, I am going to find the slope given the ordered pairs. So my y2 is negative 5 minus my y1, which is negative 3. In parentheses, put negative 3 so you don't get the double negatives mixed up here. Notice it is negative 5 minus a negative 3. x2 is 5 minus x1 is 0. So now, let's solve the top. Negative 5 minus negative 3 is going to give me a negative 2. 5 minus 0 is 5. So my slope of the line here is negative 2 comma 5. This would be my slope. So if I were to graph this, starting at the point 0, 0, I would rise by going down 2, and I would run by going to the right 5. So that is my final answer. My slope is negative 2 comma 5. Make sure you show your work when you have slope problems like this. The last example, they're wanting us to tell whether the slope of the line is positive, negative, 0, or undefined. So by looking at the chart in the previous slides, by the positive, negative, 0, and undefined slope, we're going to just label these. Remember, we talked about a vertical line. That would be an undefined slope. And my second graph here, notice we have our linear line starting at the top and going down. Think of skiing down a hill. This is going to be a negative slope. So that's it for the third example, just recognizing slopes and labeling them.